previous programs, we've seen a variety of equipment that can be used to control the operation of motors. In the next few programs, we'll focus our attention on the motors themselves. Motors are relatively simple and efficient, and when properly maintained, they're very reliable. Periodic maintenance is important to keep motors running efficiently. This program takes the first step towards motor maintenance by reviewing motor operation and bearing care, and then demonstrating motor disassembly. The remaining programs examine the care and maintenance of motor parts. Let's get started. The two general categories of motors are based on their types of power supply: direct current and alternating current. Direct current, or DC motors, require a direct current power source, such as batteries. Alternating current, or AC motors, operate on the alternating current power source supplied to your facility. The availability of alternating current is one of the many reasons alternating current motors are more commonly used. So, for now, we'll concentrate on AC motors. DC motors will be covered in a later program. As you may recall, the most common type of AC motor used is the three-phase squirrel cage induction motor. This type of motor provides the torque or turning force along with the speed control needed for most applications. Before we look at a real motor, let's look at a simplified drawing and review what goes on inside the induction motor. When three-phase power is supplied to these stator windings, it creates a rotating magnetic field. This arrow represents the rotating magnetic field. The rotating magnetic field induces a voltage in the rotor. These circles represent the rotor bars where the voltage is induced. So now the rotor has a magnetic field of its own. The induced magnetic fields of the rotor interact with the rotating magnetic field of the stator to cause the rotor to turn. It will turn in the same direction that the magnetic field of the stator is moving, but slightly slower. The different speeds maintain the relative motion between the stator field and the rotor. This relative motion is necessary for a voltage to be induced in the rotor. Now that we've gone over the basic operation of a three-phase squirrel cage induction motor, we're ready to look inside. I've disassembled a small motor so that you can clearly see the parts. Let's start off with the stator, where the rotating magnetic field is created. It includes a frame, windings, and a core. The three-phase power supply leads are connected to the motor windings here in the connection box. The three-phase windings are placed all around the stator for smooth operation. This core concentrates the magnetic field where it's most needed, near the rotor, which fits here. The rotor also has its own windings. On this type of rotor, they are in the form of metal bars that look bright silver. These bars are shorted together at the ends by these end rings to provide a complete path for current flow through the rotor bars. This black core supports the rotor bars and concentrates the induced magnetic field of the rotor. Now that we have what we need to cause the rotor to turn, we need some mechanical support for the rotor. Bearings are generally mounted on the shaft of the rotor. They support the rotor and provide a smooth, low-friction ride. They also help to maintain an even clearance between the rotor and stator when the motor is assembled. The bearings are housed in end bells. The end bells generally are bolted to the stator on each end. By housing the bearings, they help maintain the proper clearance between the rotor and stator. This clearance is important so that the rotor will not rub or come in contact with the stator. We'll explain more about the clearance later.